mark this question please. Shelby, what is the answer? Install a 250 ohm resistor in series with input terminal. Why would you do a series? You have to take the voltage. So voltage has to be in parallel. So input terminal is connected in parallel to 250 ohm. That's why you get the voltage. If it's in series, you would never get the voltage. So answer here, Vitalia, what is your answer? What was your answer?
Question 92.
Yes.
Yeah, will be in parallel 115 versus 10.
Jaideep, are you clear on this?
It's a 10 means we are going to voltage signals for parallel.
Yes.
And if you want the current signal from voltage, you have to get series and take those.
Yeah, basically we are trying to convert a 420 milliampere signal to 1 to 5 volt DC, right?
Yeah.
So the resistance value for 4 milliampere to 1 volt DC is 250 ohms. Remind?
Yeah.
You know that, or should I mention? Should I give you the calculations?
I have made this one.
Great, very
For
nice.
my once VFD I need, so it's
Yeah.
very costly. So I bought the resistor and
Good.
which is 4 to 20 amps millisignal.
Yes. So what happens is for 4 milliampere to 1 volt DC, we convert it using the formula, again Ohm's law. What Ohm's law says, V is equal to IR, we know the current, so R is equal to V divided by I is equal to 1 divided by 4 milliampere, which is equal to 250 ohms. And again 20 milliampere is to 5 volt DC. So again R is equal to 5 divided by 20 milliampere, which is equal to 250 ohms. So it is always 250 ohms. And now since we need voltage, so we would have to take it, connect it in the parallel with the input terminal. 93. A current isolator is found to be operating as follows. 4 milliampere is equal to 4 milliampere, 5 milliampere is 5.1 milliampere, 16 milliampere is equal to 17 milliampere. Okay. What needs to be corrected? Vishal? Sorry? The span? Shelby, what would you say? Okay. What would you say, Hassan?
I say linearity.
Why would you say linearity?
Linearity is not correct.
Jaideep, you said linearity?
Yeah, this last one is
I say last D span
16 milliamps.
16 to 17.
V span.
So span and 0. That's what I want.
Sorry?
I mean the span is 0.
Well, if the 4 milliamp, this only 4 milliamps, so no need for us 0 on that. And we have to go 5 to 5.1 and 16 to 17, we have to span over there.
Do you think the input is linear? Shelby, what according to you is the input linear?
No.
If it's not linear, then why won't I do a linearity test? Linearity calibration does zero, does span, and does the linearity part also. If it's not linear, why would I do just zero and span, or just span, or just zero? What is linearity? Let's look at it. What do we have? We have three values. We have three values which say 4 milliampere input is 4 milliampere output. 5 milliampere is equal to 5.1. And then we have 16 milliampere is equal to 17 milliampere. Now, if this was to be linear, only a problem of span, what would have I had here? 4 milliampere, 5 milliampere is equal to 5.1, 16 milliampere in that case would have been 16 plus 1.6 is equal to 17.6 milliampere. This would be a span issue. If for 16 milliampere, if I had 17.6 milliampere, then only span would be required. But since I have for 16 milliampere, I have 17 milliampere, span is not required. Span is required, but I have to do a linearity check, a linearity calculation, because input is not linear. Right?
Yeah, actually,
Yes, Jaydeep.
it means usually it's span and linearity, but people will usually check first linearity and then go others.
Yes.
So that's my means. So linearity is the most
Yes.
probable.
Yes. And mark this question out. A turbine flow meter has a range of 0 to 10,000 pulses per minute. A signal conditioner has been installed on the flow meter. The input range of a signal conditioner is 420 milliampere. At the current output 10.08, how many pulses per minute will be generated by the turbine flow meter? Jaydeep, what is your answer?
I will calculate this. I have not done it.
Okay. So let's take a break of half an hour. And I want you to do the there are 2 or 3 other questions which are based on calculation, Jaydeep. I would like you to do those calculations because I want to discuss it again. Because these guys here have done these calculations multiple times. You were missing in that class. Even you, Nishal. Even you need to do this calculation so that we can go. So we meet here again at 12:30 and I want you to do this calculation.